Greetings from the Department of ECE, SJBIT. Today we'll discuss about the last topic of Module 5, which is a loop antenna, and the other type of antennas which already we have discussed about helical antenna, horn antenna, aguda array, and parabolic dish antenna. All these were discussed in the previous sessions, left out with the loop antenna. As the name itself indicates, it is constructed in the form of a loop. You have two different types of loops which are available, which is it can be either a circular loop kind or a square loop kind. Circular, this is a folded dipole case, rectangular loop kind. You have one or more turns of wire forming a DC short circuit is called as a loop antenna. The loop antenna, it can be of any type, as I have told you. These are the major features, silent features of the loop antenna. They are of a small loop and whose circumference values are less than 0.1 at high frequencies, and mainly suitable for receiving the signals up to 30 megahertz low frequency. The loop antennas which are characterized by a null along the axis of the loop. Suppose if I have an axis, this is an axis where I have placed, so you will get a null. It is a broadside type indicating. So directional characteristics of the loop antenna you can improve by shielding them electrostatically. A vertical loop antenna, which is a majorly popular one, means it is placed vertically and it receives the signals in bidirectional case. So vertical loop antenna, it is shielded and receives unidirectional signal if it is shielded. If it is not shielded, it receives in bidirectional. So you'll have a high directive antenna, majorly used for direction finding applications. Vertical loop antenna, majorly used for low frequency regions to high frequency region, and the radiation pattern, usually it is a donut shape. It is independent of the exact shape of the loop antenna. The direction pattern is independent of the exact shape. Majorly used for direction finding applications. A small vertical loop, it is rotated about its vertical axis, and the plane of the loop which is perpendicular to the direction of radiation. So coming to the other features, you will have a ferrite core which is to increase the diameter of the loop, and these are used as a broadcast receivers. Different types of loop antennas that we have is cloverleaf, Adcock-Lee antennas, which are again an example of loop antennas. So the radiation pattern of a vertical loop antenna is horizontal, in a horizontal plane, which is given by this. Suppose if I consider a loop antenna, you will have a downward radiation pattern, as we have seen in the silent features. Suppose if it is shielded, you will have a unidirectional radiation pattern. So the RMS voltage of the loop antenna one can calculate as 2 pi into E RMS into A into N cos phi divided by lambda, where EM indicating maximum electric field of the wave, and 2 pi AN by lambda indicating effective height, lambda indicating wavelength, capital A indicating area, capital N indicating number of turns, phi indicating angle between the planes of the loop and the direction of the incident wave. So coming to the radiation efficiency, which is very poor compared to multi-turn antenna. For a single loop antenna, the efficiency is very poor. The dimension of the antenna, which should be in the order of lambda, which is used for transmitting types. The field expressions for small loop antenna, which can be calculated as E phi and H theta, which is in opposite to half wave dipole antenna. In half wave dipole antenna, the field are in the direction of E theta and H phi, whereas here E phi and H theta, indicating 120 pi square into I into A sin theta by R lambda square. Units are volts per meter. It is electric field intensity, and magnetic field intensity, pi into I sin theta by A by into A by R lambda square, where I indicating the retarded current, which is given as I naught into e power j omega t minus R by V naught. Coming to the radiation resistance of a small loop antenna, which is given as, you can calculate the radiation resistance of a loop antenna from radiated power. So from radiated power, by integrating the radiated power, one can calculate the radiation resistance RR value, which is for a small loop antenna, which is given as 32,000 or 31,171 into n into A by lambda square. A indicating area of the loop, n indicating number of turns, lambda indicating the wavelength of operation. Coming to the other features of a small loop antenna, the radiation resistance 32,000, this is for a single turn with the n as 1, 32,03720 into A by lambda whole square. The radiated power of a loop antenna, which can also be expressed, the radiated power first you need to calculate from the formula PT. You can evaluate as by integrating into electric field intensity E square into dA. So our H you can evaluate this as E square by Z naught into E. Z naught is nothing but the free space impedance. So this is for a small loop case. The directivity will be 1.5, which is same as your half wave dipole antenna. For a large loop case, it depends upon the wave means the wavelength and area. The maximum effective aperture of an antenna, loop antenna, which is given as AEM, maximum effective aperture 3 into lambda square by 8 pi. Loop antennas, which are effectively means extremely used in radio receivers, aircraft receiver, and for direction finding, and also used in UHF transmitters. If the current in the loop antenna is not uniform, then and the loop circumference is also small compared to the operating wavelength, then its radiation pattern is almost same as a dipole antenna. Okay, so with this derivation part of which has to be derivation of radiation resistance, electric and magnetic field derivation, which we need to do. The derivation part, excluding derivation part, as we have seen about the silent features of loop antenna and its formulas and applications. So thank you one and all. With this we have completed module 5. So covered all the topics excluding the derivation of two derivations of electric and magnetic field of loop antenna and radiation resistance of a loop antenna. Rest all were covered. Thank you.